Okay, so you should have already watched a short video about what an identity is. And this guy right here is our first identity that we are going to prove. So we have sine squared theta plus cosine squared theta equals 1. All right, so if we're looking at our unit circle and the radii, this length is 1, and we have this guy is theta. This distance right here is x, because it's along the x-axis. This distance is y, it's along the y-axis. So we are going to use the Pythagorean theorem first. So in this triangle, it's a right triangle. So this is a right triangle. We have a squared plus b squared equals c squared. So we have x squared plus y squared equals 1 squared. So now we can use our trig identity, or not trig identities, our trig ratios to rewrite this in terms of cosine of theta. So remember, cosine is adjacent over hypotenuse. So from theta, adjacent is x, your hypotenuse is 1, so we have x over 1. So we have the cosine of theta equals x. And we actually did something similar to this yesterday. So then we can rewrite it as sine as well. So we have sine of theta equals opposite over hypotenuse, which is y over 1, which equals y. So now we can take, instead of putting an x here, we can put cosine theta. And instead of putting a y here, we can put sine theta. So we're just going to use substitution. And there is our first proof of an identity. So this one, make sure you have it written down. The next one we need to write down. So let's say we want to subtract, let's see what I did first. Subtract cosine from both sides. So if I subtract cosine here, those go away. And on this side, we have 1 minus cosine. This is another part of the Pythagorean identities that I need you to write down. Okay, so now let's say we do this same thing, but now we subtract sine squared theta from both sides. You're going to end up with cosine squared theta equals 1 minus sine squared theta. So go ahead and write that one down as well. And then so far, these are the identities that you should have written. And these three are Pythagorean identities. So what we're going to do is we're going to use these 4 identities and we are going to try to prove some things. So if you haven't, make sure you pause the video and write these down. Okay, so we are going to do some proof practice. And I am actually going to all right, so we need to prove that this side equals this side based on some stuff we have written here. So when you're trying to prove that this side equals this side, when you're proving identities, you're not going to like draw a line down your equal sign and say, oh, I'm going to subtract 1 here and I'm going to subtract 1 here. So you're going to do things to each side independently. So what that means is you don't care what's on one side, and you're going to try to manipulate this side only so it looks like this side. So when you start, you got to think to yourself, which side looks simpler? Okay, well, this side obviously does. It only has sine squared theta. So we want to try to manipulate this side so it looks like this side. Okay, so let's look, first of all, if there's anything that we can change. So we don't have any tangents. We don't have any sine over cosines. We don't have sine squared theta plus cosine squared theta. That's written nowhere. We have a sine squared theta, so we could potentially change it to this. But like I said, you usually want to keep your simple side simple. So let's wait on that. And then we have this one, cosine squared theta equals 1 minus sine squared theta. I don't see any of those. So one mistake that a lot of students make is this and this they think are the same. but they're not because the identity has a squared in it. Okay, so right now we can't substitute anything in. So what other things can we do mathematically? Well, here on this side we have two binomials. So we have 1 minus something and we have 1 plus something. So what we can do is we can multiply. So I always look to see if you can substitute something first. If you can't, then look at what other math things you can do. So I take 1 times 1, that gives me 1. 1 times cosine theta, so that's cosine theta. Then you take negative cosine theta times 1, so that's minus cosine theta. And then negative cosine theta times cosine theta, so that's going to be minus cosine theta squared. So you would think you would put the squared over here, but just to keep it simple, this is all notation, the squared goes on the cosine. So that is why it's that's why it's cosine squared theta. Okay, and then I got to keep my sine squared theta. Okay, so now let's look at some more math. Well, we have cosine theta minus cosine theta. So these two things just cancel out. So I have 1 plus, minus 1 minus cosine squared theta equals sine squared theta. And if we look at our little sheet, we have a 1 minus cosine squared theta. So you might look at this and think, oh, I'm done because it's one of my identities. To be done, you have to have this side equal this side. So now I can substitute and write sine squared theta equals sine squared theta, and you're done. All right, let's try another one. Okay, so let's try this guy. All right, so first you can look to see if you can substitute anything. So we do have, okay, so let's first say this side is simpler, so we want this side to look like this when we're done. So we do have a sine squared theta, and over here we have sine squared theta equals this. So another trick, if you're trying to get something to equal cosine, you want to try to change everything into terms of cosine. So we can change sine squared theta to 1 minus cosine squared theta. So let's go ahead and write that. So we have 1 minus cosine theta minus, and then we're substituting. So instead of sine squared theta, we're going to write 1 minus cosine squared theta over cosine theta equals cosine theta. All right, so we have everything in terms of cosine over here, and over here we just have a normal cosine. Do you notice anything that we can do over here? Well, so we have a common denominator, so we have cosine theta here. So we can actually add these together. So we have 1 and then minus 1 minus cosine squared theta over cosine theta. Okay, so now we can distribute this negative. So if we just, let me rewrite that. So if we distribute this negative, we get 1 minus 1 plus cosine squared theta over cosine theta equals cosine theta. Okay, so then we have 1 minus 1, which is 0. And then we have cosine squared theta over cosine theta equals cosine theta. And then this is similar to saying like x squared over x. So x squared divided by x is just x. So one of these cosines crosses out. And you're left with cosine theta equals cosine theta, and you are done. So now there's another way you could have done this. So there are multiple ways to do these things, and I'm going to show you another way to do the same thing real quick. Okay, so to start off, you had a common denominator, so you could just add your fractions first. So let's see what happens if we do that. Okay, so common denominator, so we add them, so you get 1 minus sine squared theta over cosine theta equals cosine theta. Okay, well then this 1 minus sine theta, that's just cosine squared theta over cosine theta. And then this line is the exact same as this line. So did we get there you going this way? Yes. Was it shorter to go this way? Yes. Until you do enough of these, you won't know which way is going to be the shortest. But I just wanted to show you that there are two ways to do this one. Okay, and then I have one more. So this one has a tangent in it. So we have tangent theta times cosine theta over sine theta equals 1. Here are our little sheets, or little cheats, our little identities. So, okay, so we have a tangent, we have a cosine, we have a sine, if we want it to equal 1. So I think we can all agree that this is the simplest thing that we've got. So we want to turn this into 1. And if you look over here, the only thing that has a 1 in it is this guy right here. So we are probably going to make this side look like this. So let's try whatever we got. So we have tangent of theta equals sine over cosine. Okay, so let's right away change this tangent to sine theta over cosine theta. So we have sine theta over cosine theta. So that's our tangent. And that's times cosine theta over sine theta. So then these two cosines are going to cross out because, well, this is technically just cosine theta over 1. So when you multiply these cross out, oh, sorry, I forgot to put the equals 1 again. All right, so you're going to be left with sine theta over sine theta equals 1. And then this is just 1, so 1 equals 1. And I misspoke in my head. I was thinking that there was a plus sign in here when I said we were probably going to make it look like this. So let me explain that quick. So if you have one side that equals 1, if there was a plus sign in here, then we would have probably made it look like this. But since there isn't, it was just multiplication. We ended up going this way. All right, and that is it.